So now let's have a mixed circuit. That means we have circuit in series and parallel. So we have R1, that's 2 ohms, and then R2, 6 ohms, and they are connected to other resistors, right? We have R3, 3 ohms, and also R4, 6 ohms. Now we connect them to a battery. So remember, the first thing that you need to think about when you have a circuit is to simplify your circuit, okay? So how do we simplify them? All right. So if you look at this circuit, basically the first thing you might see is that we have these two resistors and they are connected in series, right? So basically we can calculate their total resistance first, okay, and you just add them. So it's 2 plus 6 and we have 8 ohms. Now they are connected to these two resistors, and you can see also that they are in parallel, right? So we first calculate their total resistance, okay? Now let's do this. The total resistance of them, let's call it Rp. So 1 over Rp is 1 over R3, it's 3, 1 over 3, plus 1 over R4, it's 6. Okay, so let's do the math first. 1 over Rp equals to 1 over 3 plus 1 over 6. So let's do the math like this, 6, and this is 2 plus 1. So 1 over Rp is 3 over 6, and the total parallel is 6 over 3 or 2 ohms. So basically your resistance 8 here is connected to the parallel resistance, the 2 ohms, and they are connected to this battery, right? So let me give you the voltage of your battery. Let's suppose it's 10 volts. And if you connect to this battery, you know, since 8 ohms and 2 ohms here, they are connected in series, so I can draw a simplified circuit like this, and the total resistance will be, of course, 8 plus 2 because they are in series, okay? So you have 10 ohms, and this resistor is connected to 10 volt battery, okay? So at the end you get a current that's 10 volt divided by 10 ohms, and you have 1 amps, okay? Now let's look at again your circuit. Okay, I think I'll draw a new one here. Right, so in this circuit we have a current 1 amps. Okay, 1 amp flowing in. Now this current is flowing through R1, R2, and it's divided into this wires. So it's I3 here and I4. What you know is that in series I1 and I2, they are the same, okay, and they are actually your total current. It's 1 amp. Now what about the current flowing into R3 and R4? Okay, be careful, because R3 and R4, they are connected in parallel. Therefore the current flowing into R3 I3 and the current flowing into R4 I4, they are not the same, but you can see that their total has to be 1 amp according to Kirchhoff law. Okay, so 1 amp has to be I3 plus I4. Now when you try to calculate I3 and I4, you cannot do the same thing like we did in the pure parallel circuit. Why? Because the voltage difference for each of these resistors R3 and R4, they are not 10 volts. Be careful. because this 10 volt is distributed here as V1 plus voltage in here V2 and also the total voltage in your parallel circuit, so that actually the voltage for R3 and R4 are not, they are not 10, okay, it's less than 10. Now how do we get the current I3 and I4? Okay, you know that in parallel their voltages are the same, so let me call it V3 and V4. Okay, so you have learned that V3 equals to V4, right? So that's the relation of voltage in the voltage difference in the parallel circuit. Now let's think about this. So there's a current I3 flowing into R3. Therefore, V3 is I3 times R3. Also the same as V4. V4, look, there's a current I4 flowing into R4. So there's a I4 times R4. Okay. Now from this, you can plug in the value, right? So I3 times, what is R3? Okay, R3 is 3 ohms and R4 is 6 ohms. Okay, so I3 times R3, 3 ohms, equals to I4 times 6. So I3 equals to, okay, let me do the math a little bit, equals to I4 times 2, right? So we will use this basically and plugging into this equation here. So we have 1 equals to I3 plus I4, and you know I3 according to this equals to 2 times I4. Okay, so let's put this I3 into here. Therefore 1 equals to 2 I4 plus I4, so that 3 I4 equals to 1, and then at the end the value of I4 is 1 over 3, and also you can directly get I3, that will be 2 times I4, right? So you have 2 over 3. Now we'll have I3 and I4 in your circuit, and that's actually 2 over 3 amps and 1 over 3 amps. And if you calculate the voltage in the R3 and R4, so the V3 here is 2 over 3 times 3, that's 2 volts. Okay, and now look at the V4. The voltage at R4 is I4, 1 over 3, times R4, which is 6. So you got 2 volts, and they are the same because they are in parallel, right? What about V1 and V2? Okay, let's calculate them. So V1 is just I1, which is also 1 amps, times R1. What is R1? Okay, it's 2 ohms. So times 2, basically 2 volts. And V2 is the current 1 times R2, which is 6. You have 6 volts. So if you look at this, the voltage in R1, which is 2 volt, and then the voltage in R2, 6 volt, and then the total voltage of your parallel circuit, which is 2 volt, they add together as your total voltage here, which is 10 volts. And that's actually the relation between this and this circuit, because they are in series.